Hi, hi, welcome back. Um, let's do number 2 here the same way. First thing we're going to check for is to see whether or not they have a greatest common factor. So MP, MQ, NP, and NQ, they don't all have M's, they don't all have P's, they don't all have Q's, and they don't all have N's. So there's no greatest common factor amongst all four, but we want to always check for that first. So then we group them together. MP plus MQ plus, and then parentheses, NQ plus, that should be NP plus NQ. And then we factor greatest common factor from each of them. For the first set of parentheses, what they have in common is an M. So I take out the M, and I'm left with P plus Q. And on the second set of parentheses, what they have in common is an N. And so I take the N, and that's P plus Q. And then I notice that they both have this P plus Q in common. So that then is the common binomial, the common factor. And I take it out, P plus Q. And I say, what's left of each of those two separate parts? In this part, there's an M left, so that's parentheses M. Plus, in this set, there's an N left, so parentheses, so N inside the parentheses, and I get P plus Q times M plus N, and that is factored. Now let's take a look at this other way of doing this, the box method. So you want to first check again for any greatest common factors. If we look at this example number 3, 4 has factors 2. They don't all have y's. They don't all have the factor 2 because 3 is not divisible by 2. They don't all have 3. So there's no greatest common factor, but we always want to check for that. So then we make sure the polynomial is in standard form. That's decreasing order. So 3, 2, 1, 0. This is in standard form. And draw a 2 by 2 box. So in this 2 by 2 box, I say here's 4y cubed. I put the first one in the first box, and then 2y squared. And that's this step here where it says place the first term in the top left box and the last term in the bottom right box. The last term minus 3 goes down here in the bottom right box. And the middle two terms of the polynomial can go in the remaining two boxes. So I'm sorry, I got a little ahead of myself, but minus 6y goes in the remaining two boxes. So then, once we have them in here, we look at each row and column separately. We factor out the GCF from each row and each column. And so I look at this top row, and 4y cubed, 2y squared, they have both a 2 in common. So I put the 2 out here for this row. And they both have 2 y's. And so I put the 2 y's on there, and that's their greatest common factor for that row. And then I say, hey, minus 6y and minus 3, they both have a negative 3 in common. So I'm going to put that negative 3 out here. They don't both have a y, so that would be their greatest common factor. And then I look at the first column, and they both have a 2 in common, and they both have a y in common. And then I look at the last column over here, and I say 2 and 3 don't have anything in common. The top one has y squared, but the bottom one has no y, and so they don't really have anything in common. So when they have nothing in common, they always have 1 in common. And so that is what these look like. 2y plus 1